Hello, peoples. Welcome to Pharmacology of Recreational Drugs. How are you today?
I'm good. How are you?
I'm okay. I'm hanging in. Okay, I'm just pulling up my notes here. Du Sabor. Ooh, I think I might have pronounced it right once. 21. We only have 21 people out of 50. Everybody out with the COVID? Matthew Cole's here, so life is good. And Zach Ogden.
I like the background.
Oh, thank you. It's Lake Iroquois in Vermont.
I had to do the mandatory testing, so I'll let you know.
Okay. I have mandatory testing too next week. My wife is mandating it. I came from Pennsylvania this weekend, and so I'm quarantined in my room, in the guest room until Tuesday. Then I get a test, and then I'm quarantined until the test results come in. So, life sucks.
Shorty, a little baddie.
Brian Jacobson, can you put your video back on? Yeah, you need a haircut.
It's definitely been a minute. It's been a long time.
Okay.
But you don't like it? Got some length to it.
Yeah, pretty nice. Do you do the ponytail or the knot head or anything or no?
Yeah, I can. Yeah, it goes back for sure. That's
Okay.
fine.
I like the knot head look. I got some more people filtering in here. I'm going to wait a couple minutes till we know everybody's in. Natasha's here. Hello, Natasha. Strider. What kind of name is Strider? Is that a male or a female name? I'm guessing it's a male. Strider, bring your video up. Everyone's wondering. Strider's a woman. Oh, I'm so sorry. I didn't mean anything by it, I promise.
It's okay.
Did you know, you probably know this, but Lord of the Rings, Aragorn was called Strider before they knew he was the...
Yeah, that's what I was named after.
You're named after? Okay, very cool. Very cool. What else can I give a hard time to? Cora Stone's only got one name. That's okay. Everybody else has got boring names. Okay. All right, sounds like we've settled down a bit. We've got a little over half the class. Let's go ahead and rock on this alcohol. I'm getting there. Not this one. This is kind of complicated. There it is. Okay. There we are. Oh, wait, no, this isn't what I want. I want something else. Come on, man. There it is. Okay. On Monday, we watched The Mouse Party. This is really old. I think after December, it won't play at all because it's in Flash, which is going away. But as old as it is, it was still pretty correct when it talked about mechanism of action. And that's really important to me. I like mechanism of action. That's what pharmacology really is. If we step back a little bit from mechanism of action, though, we can talk about dose-dependent effects of alcohol. What are the effects as the dose increases? So 0.01 to 0.05 blood alcohol concentration. That's, if you remember from the chart last Monday, that's about, for a man, that's about 2 drinks in an hour. For a woman, probably 1 what happens is relaxation, sense of well-being, loss of inhibition. So you're relaxing, you're feeling more comfortable. And this is cerebral cortex effects. Your alertness and judgment get impaired, right? Loss of inhibition, loss of judgment, and your coordination starts to get impaired. Now, the coordination is your cerebellum. If you remember the cerebellum from chapter 4, GABA is really important in chapter 4, and GABA is one of the important things that gets potentiated here with alcohol. Now, as we get further up, this would be, I think, about 3 drinks in an hour for a man, maybe 4. Yeah, more like 4 drinks in 1 hour, which is a lot. I mean, drinking down 4 shots in an hour, it's going to hit you pretty hard. And for a woman, probably 3. Pleasure, okay, you're going to get some euphoria here. Numbing of feelings, which is always good. It's always good. Nausea for some people, probably more first-time users, nausea. Sleepiness, it is a sedative hypnotic. Hypnotic is sleepiness, so we'll start to put you to sleep. And emotional arousal. So this is, why some people when they drink will get either very happy or very sad. There's crying drunks who will cry when they get drunk. And then also angry drunks, who are the ones you really want to avoid. Okay, where is this? Cerebral cortex and forebrain. So basically your cerebral cortex, again, is being numbed by this. And fine motor skills start to get lost, and visual tracking and reasoning, and it stops there. I'm not sure what else was supposed to be there. And again, fine motor skills, again, you're talking cerebellum, which isn't listed yet, but it's definitely getting in here. Okay, so 0.11 to 0.2, at this point, you're beyond the point where you should be driving. You should not drive at all at this high. Mood swings, anger, sadness, mania. So this is where emotions start to get amplified. If not for everyone, but for a lot of people. Some people just get kind of tired, sleepy, and out of it. But some people will get the emotions coming out. And here again, cerebral cortex and cerebellum. So cerebellum is where you're going to start to get a lot of the. It's kind of inhibiting your cerebellum. So you've got less coordination between your proprioceptors, the receptors telling you where your body parts are, what your body position is, and your cerebellum, which knows where they should be. So as you're walking along, you're kind of leaning forward as you're walking, and then normally if you slightly get off kilter, your cerebellum will bring you back up really quick. So you don't even notice that you're going off a little bit, but you are. And when your cerebellum starts to get inhibited, when you go off a little bit, your body doesn't catch you. I mean, your cerebellum doesn't catch you. So you go off a little further and a little further, and then you're stumbling back and forth. So that's why you start stumbling when you're drinking, because your cerebellum's being inhibited because you're stimulating GABA. And so it's not catching you the way it's supposed to. Okay, 0.21 to 0.3, aggression, reduced sensations, depression, and stupor. So, So some people get aggressive, not everyone, but some people will. But this is what happens to most people at this level. You start to get really tired and dopey, and stupor means you fall asleep, but it's not really like sleeping, it's like passing out, basically. So again, cerebral cortex, cerebellum, and now your brainstem starts to get involved. So this is where you get the real depression, respiratory depression, and passing out comes from your brainstem, which is mostly your medulla. And at this point, you've got slurred speech, loss of balance, loss of temperature regulation. So again, this is cerebellum stuff, speech and balance. And then you're going to higher. And at this point, if you're in the 0.31 to 0.4, most people are going to be unconscious at that level, and you could die at that level. And now you're talking the entire brain. And we'll talk about why it's, entire brain. So we'll talk about low dose versus high dose in a minute. And here at high dose, you're getting the entire brain brain shut off. And 0.41 or greater, you're talking death. And these numbers of percent are for like normal people. If you're a chronic alcoholic, this whole thing gets shifted down. No, I'm sorry. Yes, down. So that you have to get really, really plastered before you start to feel the effects, or a really, really high blood alcohol concentration before you start getting these effects. So I've got a chat here. The question is, had a patient brought into the ER a week ago, was, oh my God, 0.525. No kidding, not exaggerating. He was full on pro. What does pro mean? Pro. Christy, what does pro mean? Full on pro. Okay.
So he was a full-on pro. He he was a professional.
Yes, a chronic abuser of alcohol. Yes.
Yeah. Sorry, it took me a second.
That's
No, he was still conscious too.
I'll show you a picture later in the slides of another person who's a full-on pro.
Yes, a champ.
A champ.
We have a couple that come in regularly, and they're usually between 300 and 400.
I bet. Oh my God. Oh my God.
And that's regular.
Oof. All right. So let's talk mechanism of action now. I probably should put this later, but let's go mechanism of action. So, I'm going to change to share. So low dose is going to have effects on, hang on one moment. Un momentito. That's Spanish for those of you who don't speak Spanish. It's white guy Spanish anyway. Where is it now? Damn it to hell. Is this it? Oh, hang on. All right, I'm sorry, just this, when I try to share screen here, it shows me everything that's open, and I usually do a good job of closing a lot of things I don't need, but oops. There, this is what I want. There, okay. Okay, so low dose alcohol, kind of like in the mouse party, one of the things it does is block or stimulate GABA transmission. So it doesn't open the GABA receptor, but when GABA is around, the GABA receptor opens more. So you get more chloride coming in, which makes it more inhibitory. Remember, GABA receptor is a ionotropic receptor. It's all over the brain. It's inhibitory, IPSPs. So this is the normal function of GABA. GABA binds the receptor, it opens, and then chloride comes through in a gentle pace. And we hyperpolarize. It's more positive outside than it was, more negative inside. And then when it closes, we're done. Okay, now we're going to bring in ethanol. Ethanol is going to bind to a different site. And when the channel opens, a lot more chloride comes in. And so it's even more inhibitory. So it's going to potentiate GABA stimulated inhibition. And at the same time, the other ionotropic receptor that's all over the brain is your glutamate receptor. Glutamate receptor is excitatory. It opens and sodium comes through, depolarizing the cell. And then when alcohol is around, it binds to the receptor and it blocks glutamate. Okay, so it's blocking the EPSPs. So it's causing inhibition in two different ways at low doses. It's stimulating GABA and inhibiting glutamate. So in both those things are causing inhibition in the brain. Let's try a different share now. Back to this. Okay, so that's the GABA stimulation, more chloride coming through, more inhibition. GABA blocking glutamate blocking. So it does two things to block glutamate. It blocks the glutamate receptor, so glutamate is less effective, and it also blocks glutamate release. So in both ways, it's causing inhibition. Okay, high dose alcohol. So that's low dose alcohol. It's very specific. It's just affecting specific receptors. With high dose alcohol, though, once you get into a higher dose, here's your action potential without any alcohol, right? You've got, so that's going pretty quick. Let's make some explication here first. Here's your sodium channels. Here's your potassium channels. So this is the, in axons, the upsweep of the action potential. Let's back up. Depolarize, repolarize, depolarize, repolarize. So the action potential is going this way down the thing. Okay, depolarize, repolarize, depolarize, repolarize. This one's harder to see than a lot of them. Okay, with alcohol. So basically, ethanol can dissolve in the membrane. So when it does, it makes the membrane more fluid. So the fluidity of the membrane is really important for the function of membrane proteins. And it's regulated by the cell to make sure that, you know, the fluidity is exactly right for the membrane to work most efficiently. When you put some small nonpolar molecule in your brain, it dissolves into that membrane, stops those hydrophobic tails from interacting with each other, and it gets very loose. And because of that, the membrane proteins don't work anymore. This is the same way that anesthesia works, the inhaled anesthesia, like nitrous oxide or chloroform or ether, halothane, all those inhaled anesthesias. All they're doing is going into your brain and changing the membrane fluidity, which is just going to shut everything down. So that's what happens here with high dose alcohol as well. Okay, so normally you've got your channels working normally, making action potentials. With alcohol around, this all just kind of stops because you're changing the membrane fluidity. Oops, okay. Hang on 1 second. I want to bring up my notes real quick so that I make sure I'm not forgetting something. Okay, high dose, low dose, indirect effects. So that, so indirect effects. So do I have it here? No, I do not. Okay, so indirect effects with alcohol. At low concentration is going to indirectly release dopamine and endorphins. So it's not working on dopamine, it's working on GABA, but by stimulating that GABA, we're getting dopamine release. What does dopamine mean? It means euphoria and it means addiction. So this is why, and opiates too, we'll see later, also cause dopamine release. So both of these effects are causing euphoria, and that's why alcohol can be addictive. It's not nearly as addictive as a lot of the other things that really release dopamine, like cocaine, amphetamines, things like that, but it is still addictive. Neurons with GABA receptors and glutamate receptors release dopamine and endorphins. GABA causes release of dopamine opioids, which gives a sense of well-being. Opioids release dopamine, euphoria, reward, and addiction. Okay, so those are indirect effects of low-dose alcohol. Okay, so behavioral effects then of alcohol include a mixture of stimulation and depression. We talked about this earlier, but in general, mild euphoria, loss of concentration, memory, sedation, and muscle relaxation, and it's anxiolytic. Anxiolytic, that means it decreases anxiety. Depresses cerebral cortex function, both low dose and high dose effects, inhibition of cognitive and motor skills. So if you remember, we were talking about willpower and the cerebral cortex, right? Let's bring that up.